Eric can just talk to you about this from a concept point of view, and then I'll get into detail. Here's a recommender data set that is used in a particular recommender. And maybe you just want to give everybody a quick view of this data set. It's the one with so what you have is you've got a data set that's got all the base features from a customer and all the offers that they've taken up over time, where you've got them essentially, we prepared them on a distribution so that we could see how customers would take up products in the context of a particular recommender's behavior.
So yeah, this data set is one that we created for simulating recommendation and recommender models, and it has some sort of real-time features built into it. And the idea is, I mean, I don't know if anyone remembers from the recommender discussion that we had, there's a few ways that you can design recommender data sets in the context of having not too many products and quite a lot of data about the user. So this is a situation where it's not a Netflix situation where you have, or that Amazon where you have sort of a huge number of things that you could recommend to a sort of relatively small number of people. This is more of the sort of financial services situation where there's a relatively small number of things that you'd want to recommend, and you have quite a lot of information about people. And the way that this set is laid out is to say that we're going to train it on what was the most recent offer that all of these people took out, and train a multinomial on that to predict which offer they're most likely to engage with. There's a bunch of other ways to do it. I mean, I won't go into it now. We did a whole meetup on it. I'm sure we'll revisit it at some point. But that's the sort of general structure. And the idea is that there are, as Jay was saying, a bunch of pieces of demographic data around things like, you know, number of children, the level of education, all that sort of stuff. And then also some in the data has like real-time features, which in this case is their engagement personality. So the balance is almost a illustration of a incredibly useful, seemingly quite basic, like contextual real-time feature. So often with these recommended, particularly in financial services, if you don't have that real-time functionality, you can recommend stuff to people that they can't actually buy anymore. You know, you might, because it's not there, you know, when you ran your recommender previous night, they had however much airtime or however much money in their account, whatever it was, and that's since changed during the day, and then they get your message and it's now irrelevant. So having that balance as immediately as possible is very useful. And personality also looks at, you know, how they've been engaging with that platform, with your platform, to get to the point where you're giving them an offer. Are they in an experiential, explorative mood? They've been looking around, or are they very intentional? They're just trying to get to the point, and sort of uses the previous steps in your journey to predict what you want to do next. And I think those two kind of, you know, we speak about, you know, real-time predictions, but I think a key part of that, which comes through, I think, quite obviously in those features, is just the benefit of having the real-time features available as well. You know, it's like a key part of getting the benefit of being able to make your predictions in real time is to have your features in real time too. You know, if you're only refreshing your data in your feature store overnight, then real-time predictions are probably not as useful for you. You know, you need to have, not every feature needs to be real time, obviously. You know, like age, you don't need to update people's age by the day, number of children, although if that does change, it's a very good trigger. But yeah, so that's just at a high level what that data set looks like. Apologies, it took a while to remember which data set it was.
Oh, sorry, Eric, I just sprung it on you just before this. But what happens now is that you've got a multitude of different ways in which you can train the model. So in this case, there are a couple of models that can be trained, and you can even get your recommended to start selecting between them and have different hypotheses. And you also have a real-time propensity model to in real time decide, you know, how and where people, you know, are likely to engage. So you will then set your recommender so that you can decide if it needs to remember what it's given it before. Because if you think about it, in a normal LSTM or a deep learning model that deals with long-term, short-term memory related, you know, kind of functions, what you want to know is that if I'm going to present somebody to something and they purchase it immediately, you want to know that you cannot go and offer them that same thing again. So what you need to do is to maybe pitch the same product until they buy it, or once they bought it, you then switch to a new category. Or what you do is, if they're not buying it, you want to keep on recommending it until you've exhausted what you think the number of options are of presenting it to them. So what you then can do is that you can set it up in a way that you say, I want to present this offer, and I want to use, say, a Bernoulli sequence or some other numbering mechanism to decide that every second, every third, fifth, eighth, whatever offer is something that comes from that comes from the cache, because it's already recommended, and I really want to try and sell this thing to this target that I'm selling it to. And then you can have a multitude of other mechanisms to then guide it in different directions. So there are various options that you can use to configure the kind of entire deployment of how you would get that into the deployment environment. So what I'll do now, I'm going to show you what it looks like on a dashboard. So this is what it looks like when it's in production. So this is an example of that simulation that I ran. So it's running on a local infrastructure. So you'll see that it's only sitting at about 10 milliseconds in response time. Normally this one will be about 2 or 3 milliseconds in response time when you put it into a broader kind of data center or a high-performing data center. And I'm going to kick off a simulation in a moment and then show you how we will typically track the various criteria that is normally worth keeping an eye on as you have this kind of environment in production. What you'll see is that some of these panels are empty. That is just because I'm not running the aggregator in this simulation, and there's an aggregator that does throughout a day and a month, whatever. It automatically aggregates your data so that and it works out a number of different kind of distributions, so you can see other analysis. That is turned off at the moment, so you only will see all the real-time responses. Then the other dashboard that I'll show you is the dashboard that is typically used by the data scientist. So in this case, it shows you how many offers are presented and how many are accepted within this particular simulation set. And then the explore exploit is just a very basic way in which you could set, in this example, your multi-arm bandit. And then you want to track model performance, and you want to start tracking this different parts of essentially the different base metrics when it's in production. So you've got so many offers that have been sent out, so many that have been, and you really want to understand the offers plus the scoring of what kind of score is more accurate. Normally, this is purely for visual purposes. You would normally run behind the scenes. There's an engine that will go and calculate this to make sure that the feedback loop happens completely seamlessly. So this was just run earlier from a test point of view. So what I'm going to be doing is I'm going to say I'm going to track the last 5 minutes, and we're going to keep an eye on it every 5 seconds or so. And when I kick off the simulation, you'll be able to see how that runs. So we're also going to make this the last 5 minutes, and we want to pick up the last 5 seconds of timing. So normally these kind of dashboards will sit on big panels in your operations center or in your CEO's office that's going to want to track, revenue made or whatever it might be, because there are a series of these different dashboards available normally. So what I'm going to do is kick off the simulation, and within 5 seconds you will now start seeing results popping up. So you can imagine throughout the day, if you've got thousands of millions of people busy using what you're using around the world, you'll be able to track, in this case, it's just tracking the performance coming in. You can see there it's hitting 27 milliseconds because of all the stuff running on this local environment. And if I go look at my scoring dashboard, you can see your initial scores popping in. So if you let's say we zoom in on a few of these and you start looking at what it's doing, you can now start seeing that in this case, the explore versus exploit is that it's exploiting obviously a lot more than it's exploring, and that's what you're seeing here. So that means that it's fairly consistent in what it's testing in the context of a client base to what is needed. You can look at the score of the model based on whichever input parameters are coming in. So from a data set that it hasn't seen before. So we just keep on refreshing this. We'll see it will load. Let's bring it back to the last 5 minutes. So you can see that what happens now over time is you can keep on tracking the performance of, in this case, it just shows you that you've got your recommender recommending. You've got the scores of the offers that are going out. You can see that in this, a lot of these scores are sitting at 0.9. So that means that it's recommending items that are already been trained to tell that it's going to be successful. And then you can start seeing which ones have been taken up. Since this is a simulation, you're not going to get a true reflection, but at least you'll be able to see that, yes, like you can see that there's, in some cases an offer that is accepted by somebody with a low score, and in other cases by a high score, because over time you're really interested in those deltas, because it's going to tell you about model drift and the changes that happen in your data set over time, and especially the client base that this is normally targeted at. What is also important is to start understanding how the model is distributing the offers and how they're being taken up. So in this case, you can see that in this simulation, it's giving these as offers and it's accepting it at this rate. So you can see that this product in the green bar, the product 0, by default is the one that is more popular than this particular product. So what you might want to do is to run a separate campaign to have an offer, especially if you know that this particular product is highly profitable or that it's not being used by people that you want to use. You want them to use this product. You want to be able to then provide additional offers, and you want to then skew this data. So that's what we often call induced bias. So you almost want to have bias towards a particular product so you can start tracking, how many people are taking it up. So at the moment, there's no caching turned on. So that means that we're not remembering anything. So we keep on recommending new things all the time. We're not remembering any old product. And you can just, again, look at the difference between, for this particular customer number, what the typical score is, and then how many of those they've accepted. And you see in this case, the acceptance this gives you a 1.0. That's kind of how the graph is configured.
Okay, Jay, it's Brian. So, if you go to, what do you call them, pizzas and Manhattans or whatever, but if you go to that Manhattan thing, obviously the higher the graph, the better. And then any CEO would look at that and kind of go, okay, green is fantastic, and he knows what the green is. It's product X or whatever.
Yes.
Are you then able? So let's pick a retailer, and a retailer is maybe he's got a whole lot of stock that might be becoming old or redundant, whatever.
Yes.
Okay, you could use your clever software to launch a promotion or whatever on that particular product. Yes. In real time and get the oaks, put it on discount or, whatever that you can do.
Yes, definitely. Yeah. That's exactly the case here. So what you could do, there's another feature, what's called a budget, or basically it's a matrix tracker. Some clients call it a budget. And what it does, it can track across multiple dimensions the criteria of that product being recommended. So you can create an induced bias. You can keep on, push that product to a certain segment, to a certain geography, to a certain group of people, and then what you can decide is that if it hits a certain threshold, you want to provide certain discounts up until the point where you don't want to provide anymore.
Yeah.
So that can be dynamically configured. Yeah.
Sorry, that can be done in real time.
Yeah. That's all done in real time. Everything. Okay. So that means you can have loyalty calculations in real time, pricing adjustments in real time, and in this case, this one doesn't do much of a pricing adjustment. You can see it sitting around 10 milliseconds. In a current simulation on this local desktop. So when you run this in a data center and you've got a complex case, we find that complex cases on our desktop test environment, we call it, will normally run at about 35 milliseconds. By the time it hits, in company data center, it sits at about 7 or so milliseconds. So that means you can still do real time, loyalty and interfacing and all kinds of additional calculations while producing that result in a very short
and if you've got like 100 items left, can you induce whatever you call it, 100 items, and then you switch it off?
Yeah. So what you do is you can take your total, if you have, say, a total stock base, and you want to flatten it all out. What you do is you take your most slowest moving items and you want to prioritize those maybe initially first to get those out the door, because the fast moving is going to move fast anyway.
Yeah, correct.
Then what you then do is that the recommender, every time that it decides on the explore exploit, will keep on deciding on the explore that it must keep on exploring the items with bias. The items that you are disproportionately giving it a weighting to because it's not selling those just yet.
Okay.
But you don't want to just sell only that for a period. You want to split it throughout the period. So you can decide that you run 2 overriding time campaigns. One is for a short period, so there could be an hour, a day, a week, whatever. And then you have one overriding that runs, say, for a week. So you can have your fast-moving items that you always have in stock as your overriding campaign. Yeah. And your detailed campaign could be on a daily basis. And especially, I think, for perishables, maybe, something like that. So if you got, and you really want to get rid of them and you want to go and target, say, you're in a city block, whatever it is, and you want to push out messaging to people to say, listen, can buy your bananas today and you're going to get a special, because you know that you're not going to be able to sell them anyway, then you can run that, definitely. But that will then pop up on here. What will happen on your dashboard then is that you would have a number of models listed here. In this case, you see it's running off one model. This is kind of one model to this. This is a out-of-the-box picture, but you would have a stack of models over here. We also got versions of this dashboard that deals with, especially if you've got like 15, 20 models, to start comparing the models only and their performance, and then you can come back to this, to any of the other kind of details.
And can you configure these dashboards to be as user-friendly to each customer or customized per customer? How?
Yeah, completely. I mean, this was done as a generic product, and I know that when I saw what this looks like on, some client sites, it looks very different now. I mean, they've adjusted this quite a bit. If you think of like this one here that shows you the performance, over time, what a lot of clients have done is they've taken this top dashboard here and put it in the command center. Sorry, it took a while to show up on it. You see this one here, it took a while. At least they took these and put it into the command center, and they take the detailed, items, the performance related criteria, and then show that to the people who analyze, in this case, like the API performance or the feature store. So like in this case, you can clearly see that if you had to take the API out of the picture and you look at the feature store performance alone, that's where most of the performance, kind of sits in most of these predictors where there's no caching, but you can see that it's hitting around 7 milliseconds. So that means that a big part of our dependency is the data engine that we've got to make sure that it can read that velocity of data the whole time, and then make sure that it can make the recommendations. Yeah. So these are very crucial graphs to track over time. You can also see that on this port number here, what a lot of clients would do. This is an example of showing, if you say, six horizontally scalable scoring. This 6 horizontal scale means that you can put 5,000 transactions a second, or maybe even more, through this, including with the API and overhead with that. Yeah. Basically, this is what, if you had to think of people out there on their devices getting recommendations throughout the day or buying, if you had 100 customers, then a lot of what you see here is not really going to be that interesting. But if you sit with, 1 million, 2 million, 20 million, 55 million, or some clients, 100 million customers, then it changes the game entirely, because that means that you really want to understand through your entire geographical spread of your product where things are being sold and how, and then know how you can then, act on that.
I mean, it's incredible. I just think the ability for you to nudge anybody, while he's active on a customer, and nudge him in a direction that, force feeding him almost. I mean, I think that's just unbelievable technology. And I don't see that happening at the moment. I do online shopping and 60/60, et cetera. I'm not getting nudged at the moment, to do anything. Yeah. I mean, I think this would be a complete, as I called it, a game changer.
Yeah, and I think what is, great for people who get involved with us now, obviously, if you think about our early days, this is our 3rd generation scoring engine. So that means it's gone through 3 entire rewrites just about. We're working on, Eric and obviously designing the future now of what the next one is going to look like, with a whole new bunch of features around additional reinforcement learning beyond what we have now already, and additional mechanisms of doing real-time testing and the like. And that just means that this ongoing matching of making sure we've got dashboarding that can show what actually happens, because most of what we do, you can't see, It's kind of bolted into the fabric of what you do. So that complicates it sometimes, because so how do you demonstrate this? So we actually in conversations with, companies at the moment, to find ways in which we can create demos or a visualization to show this is physically what it looks like when you use it, because otherwise you have to go to, like Vodafone or whatever it is, and go play with the app, and then you can get a feel for the demo. Yeah. But the idea would be to have kind of a full, kind of like a visualization of seeing exactly how the recommenders shift.
And preferably with their data.
Yeah. Yeah. I mean, the thing is, we want to create, what we're working on at the moment is, an approach to have this whole stack into like a demoable container, so that somebody can go spin up and say, well, this is what a recommender can do for me, and let me go and try it out and go tweak some of the details myself. I mean, that's kind of the focus.
There was just a comment from Jacques who said maybe like a salesperson responding to real-time customer behavior.
We are in conversations now with, in actual fact, with a big global outsource company, is to figure out how you can bolt the personality recommend and everything into like an agent-based system. So you can have either human-facing recommenders, or you have customer-facing recommenders. And the idea is that you should be able to get that salesperson that is either face-to-face or digital, to get an action recommended to them, and then keep on testing it throughout the day to see if it's working. Because in this example, what happens is, if you want to know how much money you are making or losing, all you have to do is turn off the recommender, because you can clearly see like in this simulation, what money you were making by this particular recommender running. So that means that there's a distinct line that you can draw, because there was an era before you had this, and let's say it was human-based or current campaign, and you continue with your current campaigning. Then what you then do is you implement a case like this, and you then bolt it in, and you start doing it in parallel. And whatever money you're making here is essentially like a sales force that's automated in its entirety, and you can clearly see what it's worth to you. Because if you did not have it, there would have been no money whatsoever. So you can start filling in gaps in the market and start selling in areas that in normal conditions you would not be able to do. So it's quite vivid with what you can then track from a performance point of view.
Yeah, just one quick question on that. I mean, if you've got these recommenders, in place, you don't want to be turning them off to see whether they were working or not. How close to, canary deployments and blue-green deployments is the system?
Yeah, listen, we've tried all sorts of mechanisms, and I think that realistically, the only way to know that you're alive is to stop breathing, isn't it? So that means that, if I can use that analogy, so what we've done is we run, and if you look at in this environment, if you've got 8 running, and you know that you've set up some of them to only focus on certain segments or whatever it is, the only way to do the testing is to sometimes during the day turn it off for 5 minutes, turn it on again, and track those deltas, as like a set analysis. I'm not sure if there are, how else would you truly know that it is, doing what it's supposed to do, that it is contributing the way that it's supposed to contribute.
I have a quite a simple recommendation in that respect that I've seen done in a very large payment processor. And what they do is work on the last digit of the customer ID. Okay. So they can deploy new code or new something to 10% of their customers without really doing much in the way of coding, because they just base it on the last decimal.
Yeah, no, there is a standard practice. So it's not just about the last digit. You can pick all sorts of groupings. So no, we do that. But realistically, even within that grouping, you still want to do the control test. So that means the only way that you truly know that something is going to have an impact is by not having it and then having it. So you'll see that, Spotify and Facebook and all the global, even kind of digitally focused companies all do tests throughout the day by turning things on and off. Just that if your base is much bigger, you just do it for control groups, for smaller groups, and you do it for shorter periods of time, especially if you've got high volumes of activity. So an example is that if this was for something that has got to do with selling cars, you normally would not typically run these kind of tests. But if you sell high volume items at lower prices, then it is fairly easy to do that, because you can then see, where the impact's going to be. But I mean, yeah, that's definitely an ongoing interest of ours, is to figure out how you can truly measure that impact. Because in this case, the impact is just, if you run this in parallel with your existing campaigns, when this goes down, whatever revenue shows on your revenue line, if that's not there, you got nothing, because this will perform its own set of actions. So that means that you don't have to turn it off, because you know that while it's running, it runs in parallel. If it does not run and it is your primary channel of recommendation, then the only way to know is to then take control groups off your stack and then measure them in the time delta between what's happening today and before. So yeah, I mean, there's probably a few ways in which you need to think about that.
Interesting stuff. And of course, you've got to make sure it's at the right time of the day or the right time of the month, the right time of the week, and all the rest, so that you're comparing apples with apples. Yeah.
Listen, exactly. And that's why, if you think of something like banking, telephony, retail, anything, insurance, any of those sectors, most of what you do will have a high impact on the time of the day when you do that. So if you want to know if your lunchtime campaigns are working in selling insurance, the only way you're going to know if it's working is by turning it off on one segment and not another, or one control group and not another. So that's an ongoing, it is tough to find the right balance to figure out if it is really contributing.